Welcome back. Today we're talking about transformations to exponential functions. So let's go ahead and take a look at some vocabulary terms. So the first vocabulary term we need to look at is parent function. Parent function is the most simplified form of a function. For exponential functions, that parent function is going to be f of x is equal to 2 to the x power, or y is equal to 2 to the x power. We can transform in three ways. We can do a translation, which is a shift vertically or horizontally, a reflection, which is flipping the graph over the x-axis, or dilation, which is increasing the steepness. Now let's take a look at each transformation in more detail. So here in reflection, we can see our exponential function that we always use, y equals a times to the base raised to the x power, plus k, which is going to be our asymptote or our constant. A reflection is going to be changing the lead coefficient to reflect a value less than 1, which will reflect the graph over the x-axis. So you can see here that my red curve, y is equal to 2 to the x power, and then my blue curve, where I typed them both in the decimals, I can see that y equals negative 2x, so negative 2 is going to be less than 1, and that's going to cause my curve to reflect over the x-axis, and I can see that represented in my Desmos graph. Now let's take a look at the next one. So here we're talking about dilation, and we can see the changing b will increase or decrease the steepness or rate of change of our line. So we can see our parent function there, we've multiplied by 2 and raised to the x power, and we're going to change that 2 to a 24 for our next function, and we can see how much steeper our line has gotten. It's gone way steeper, closer to the y-axis. So when you change that b, you're going to be changing the steepness of your curve. So for translations, we can shift our graph in two ways. Changing the k will shift the graph up or down on the y-axis, and it's going to move that asymptote that we talked about last time. So for example, if we put a +4 on the end of our parent function here, that's going to move our graph up on the y-axis, and it's going to cause our asymptote to go up to 4. Changing our leading coefficient will change the initial value of our graph, so the y-intercept, for example. So we'll have y times 1/4 times 2 to the x power. That's going to cause our graph to go down on the y-axis, so down to 1/4, and our graph will be more curved outwards as opposed to our original parent function of 2 to the x power. Now let's try and do some of these on our own. So here we've got to use key vocabulary to describe the transformation to the parent function y equals 2 to the x power. So in the first one, we can see that y to the 2 to the x power is still there, but we've changed the leading coefficient to 3. We've done this, and therefore the curve's starting point will change because we changed our leading coefficient. In the second one, we can see that we've changed the 2x, 2 to the x power, to a negative, so therefore that's going to cause a curve to reflect over the x-axis. We also have changed the asymptote to +4. So therefore, we're going to change the starting point we're going to reflect over the x-axis because we changed that to -2. And we're going to move up the y-axis by 4 because we've changed the value of k to +4. For the last one, we can see that we've changed that leading coefficient to a 2. So again, that's going to change this curve's starting point. And we can see that we've added 3 on the end. So therefore, that's going to change our asymptote as well. That's going to move up the y-axis 3 because we've changed that value for k. That brings us to the end of this set of notes. It also brings us to the end of this video. If you like this video, go ahead and throw us a thumbs up. If you love this video, go ahead and throw us a sub. And we will catch you in the next one.